Here is your 8.2 inverse function packet review / everything else. I don't know. All right, inverse functions. So last section we talked about composition, we talked about addition, subtraction, basically operations of functions. Now we're going to talk about inverse. Remember the word inverse stands for opposite, okay? So if I have addition, the inverse is subtraction. If I have multiplication, then the inverse is your division, okay? Basically the same kind of thing we've talked about before. In this case, when we talk about functions with inverses, what we're going to be doing is something a little bit different. So inverse relations, some of these things you will have on your paper, some of these will not. You're going to have to add them. So inverse relations, the definition is right here. Basically what we do is we take the x and the y, the interchange, right? We interchange the input and output of the original relation. So the input is our x and the output is our y. And basically this means that the original domain and range are also interchanged. If you recall from when you first learned about functions and graphing, things like that, x is the domain and y is the range. So the domain, remember, it goes left or right, and then the range would go up or down. This would basically mean the numbers that are included in the list of relations. Okay, so in this case here, the original relation is here, where x is 0, 1, 2, 3, 4, and y is 6, 4, 2, 0, negative 2. You can see them graphed in blue. On your paper, it's kind of like all black because you don't have, can't afford color. But here you can kind of tell the difference here. So all the blue is the original relation, and you can see that it goes in a straight line down. Okay, so it goes like this. There we go, like that. If I were to graph them, I'm not saying I would. I'm just saying if I were to. Then the inverse relation is basically what I do is I take the x and y's and I flip them. So the y is now the x, and then the x is now the y, just like it says right here in these little boxes, these little cool little big square brackets. Okay, so now what happens is that first line that we just drew turns into this new line when I take the inverse of it. The graph of an inverse relation is a reflection of the original relation across the line y equals x. Okay, the reason why it's y equals x is because x and y, if they are interchanged, I still get the same thing. That's why y equals x is the line of reflection. Every inverse relation has to be graphed over that. Basically what happens is we're flipping the line. Okay, that's basically what is going on. We'll talk more in detail about that when we get into some application problems. Okay, but this is the kind of premise to what we're doing, and it's not going to get much harder. This is only one page of notes. This video is going to be very, very short, and hopefully your power sign will go all right, and then the Unit 8 test and so on. Okay, so let's get into some examples here. Okay, these are the 4 examples that we're going to go through, and then you'll have 2 examples yourself to do. Okay, this is all you need. We'll go through every single thing that we need here, and then you'll have some practice problems to work on and so on and so forth. So to find an inverse relation, okay, what we're going to do is we're going to switch the x and the y, and then we're going to solve for y. You notice all of these are solved for y. Just because it doesn't say y down here in examples 3 and 4 doesn't mean it's not a y. Okay, we've talked about that before. So what I'm going to do is I'm always going to write what the original one is. I don't care if it's already written there. Then I'm going to kind of make an arrow saying, okay, now I'm going to switch. You don't have to say switch, but this arrow to me means switch. So x equals 2y minus 7. So all I did was take the y and put it in, just move them, okay? Now I'm going to solve for the y. Well, how do I do that? Well, I got to add 7 to both sides, okay? So now I get x plus 7 equals 2y. Well, now I got to get rid of the 2, divide. So I get y equals x plus 7 over 2. Now, we need to understand some things. In these instances, I'm not worried about them so much because we don't actually have a function name. Okay, it's just y equals. But in example 3 and example 4, we're going to have function names and we have to understand them. So when we get to those, there's going to be some kind of weird thing that we're going to need to make sure that we are using. Okay, and then every subsequent one, I believe, on your practice and on your power assignment will be ones that look like these with h of x, g of x, f of x, s of x, whatever they are. Okay, we're going to have all those. So example 2, here we go. So again, I got y equals x squared minus 5, original. I'm going to switch the x and the y. So I get x equals y squared minus 5. Well, I need to get y by itself, so I'm going to add 5. X plus 5 equals y squared. Well, now I got to get rid of the squared. How do I do that? Haha, I square root it. I square root it. So I get y equals the square root of x plus 5. Now, we have to remember something. Because my exponent, when I took the root here, what root did I take? I took a square root. Well, what's the index? It's even. If you guys recall from 6.5, okay, we actually had, when we flipped some things and we get 2 answers, right, because the index was even. Well, this is an even index. So I get 2 answers, a plus and a minus. And that is our inverse for this particular example. Okay, so here's what's going to look like. Just a real quick thing here. This graph is x squared minus 5, so it's actually like this, okay? That's what it looks like. Now, if I were to graph this part here, it would look like that. That's called the inverse, okay? Because it's flipped over the y equals x line. All right, we'll get into some applications as well. Okay, example 3, I have y equals, not h of x, I'm going to change it into y. Okay, 3 over 2, x to the 4. So now I'm going to do, switch my x's and y's around, right? X, y there, boom. X equals 3 halves y to the 4. Great. Now I'm going to multiply by the reciprocal, which is 2/3. There's a couple different ways to do it. One is you can just multiply by 2 and then divide by 3, like proportions. That's okay too. Doesn't really matter. As long as you get the same end result, that's okay. Equals y to the 4. Now I'm going to take the 4th root, because that's what I need, 4th root. Okay, so I get y equals the 4th root of 2/3 x. Now, what did I say up here? It's an even index. This is an even index, so it's plus or minus. Now, you can leave your answer just like this. I'm not testing you how to rationalize fractions and all that stuff, which you can do from Unit 6, but I don't care about that right now. This is fine. I'm going to leave it like that, okay? Leave it like that. Leave it like that. Leave it like that. But what did I say before? There was something special about example 3 and example 4. This is actually h of x, okay? This is the original function, and then this is the inverse. So here's how we write the final answer. This is not the final answer yet. We're not done. So the final answer is written this way. H inverse of x, the inverse of h of x, okay, that's how it's read, equals plus or minus the 4th root of 2/3 x. This is your final answer. And if your function has a name, which it does, over here and over here, I'm going to need this -1. It's not h to the -1 power, it's the inverse of h of x. Or the inverse of h, okay? That's how we're going to read it. It's not -1 power, I don't flip it in that respect, but it means inverse. All right, let's go to number 4 here. Okay, again, this is a y, so y equals 2x to the 3rd minus 5 over 9. Let's flip, flop. Flip it, float. Don't float. Okay, x equals 2y to the 3 minus 5. Like that old lady in the wedding singer, Wedding Crashers, or I don't know. She's singing that hip hop, hip it, don't stop. 9x equals 2y to the 3rd minus 5. Gonna add the 5 over, right? So I get 9x minus plus 5, ooh, almost made a mistake there, equals 2y to the 3rd, divide by 2. Okay, I'm going to kind of move up. I don't have a lot of room there. I kind of write really large. I'm sorry. 9x plus 5 over 2 equals y to the 3rd power. How do I get rid of the 3rd? I got to take the 3rd root, right? The 3rd root. So y equals the 3rd root of 9x plus 5 over 2. Now, this index, is that even? No, so I don't have a plus or minus. I just have one answer, okay? Don't have a plus or minus, it's just one. Now, am I not done yet? Why not? Oh, because it's g of x, so this means this goes away, and it becomes g of negative 1x, right? G to the negative 1x, or the inverse of g of x. The inverse. Oh man, the inverse. Oh yeah. There's your answer there. Okay, you guys have 2 problems below. Please work on them and then hit play. Okay, actually it's number 1. I don't know, number 1 maybe? I don't know. So find the inverse of that. Okay, so I get what? This is y equals 4x to the 4 plus 10. I'm going to change it. X equals 4y to the 4 plus 10. Bring that over. X minus 10 equals 4y to the 4. Divide by 4. Right, so then this is gone. Then what? I got to take the 4th root of both sides, right? 4th root. So I get the 4th root of x minus 10 over 4 equals y. Yeah, but I don't like it. I like the negative 1, right? F of inverse, right? F inverse. But then what did I forget? Because this is even Stevens. Remember that? With Shia LaBeouf, I don't know what his name is. That's your answer there. Number 2, y equals 3x squared minus 4 over 9. Change it. 2x equals 3y squared minus 4 over 9. Multiply. 9x equals 3y squared minus 4. Add 4. 9x plus 4 equals 3y squared. Divide by 3. Divide by 3. 9x plus 4 over 3 equals y squared. You notice I'm showing every step, but again, you get better at this. You can skip some steps. As long as you're right, you're okay. All right, I got y squared. What do I got to do? I got to square roots this. Okay, so square root it. So the square root of 9x plus 4 over 3 equals what? Equals the f inverse. Okay, am I done? No, I'm not. I got to put a plus or a minus in front because it's a square and even root. If you forget that plus or minus, then you will be wrong. Okay? That is it, ladies and gents. That concludes your 8.2 video. I believe it's probably less than like 15 minutes. It's like a world record. All right? But if I keep on talking, it's going to get a lot longer. So in that case, take notes, do work, be successful. Peace.